Hi everyone. Today we are going to learn about heat transfer by convection, lesson 74 in science. You will need your energy booklet, a highlighter, pencil, and colored pencils. So let's just do a little pop quiz. The first one here, which is not a fluid? Gas, solid, or liquid? That would be solid. What about which electromagnetic waves would enable us to see light? Ultraviolet, X-ray, or visible light? The key word here is see, so your answer would be visible light. And true or false? Metal is a good conductor of heat. True. And why is that so? Because it's easy and it's fast. Once hot, it stays hot for a while. Okay, we have our compass rose here in for north, east, south, and west. We have our sun shining down on this person, which that's a good example of radiation because we don't have to touch it, we can feel it. But looking at our compass rose, we know that our sun is more so in the west direction. And so your shadow, whenever we talk about light, the light doesn't go through you, so your shadow would be on which side of my little stick figure here? On the side of the sun or the opposite side? Well, since light doesn't go through us, we know it's going to be on the opposite side of the sun from us. If it were morning time, we know the sun would be on the east side and our shadow would be over here on the west. By the way, a good acronym for north, east, south, and west is never eat sour watermelons. So, in our last lessons, we've learned about conduction, which it's the transfer of heat between two substances. So if we look at our green ice cubes and we have our warm water, what would happen? The ice cubes would melt, right? That is correct. Because why? Because the heat is transferred to the water. And this is an example of conduction. So does the heat move from the warm water to the ice water? Or does the heat move from the ice to the warm? Well, if you will recall, we read on page 12 in the very first paragraph, heat always moves from a warmer substance to a cooler substance. You should have that highlighted in paragraph 1. So heat would move from warm water to ice water. Now, we know heat is transferred in 3 ways. We have up here radiation, conduction, and convection. And there's 3 matching pictures. So looking at the pictures, looking at the words, which one goes with which? Radiation? Yes, naturally would go with the sun because, as we said, we can feel the heat from the sun, although we don't touch it. Conduction. That's when 2 substances meet. They have good direct contact with each other, such as the hand and the ice cube. And we have convection, which is dealing with the hot air in this picture with the hot air balloons. Sorry about that. I have a short video for you to watch on the transfer of heat.
What we're really talking about here is how energy moves, specifically heat energy, and how it gets from point A to point B, whether it be here on the surface of the Earth, up in the atmosphere, or even out in space. Heat transfer occurs really in three ways, and these include conduction, convection, and radiation. Let's take a look at each of these, starting with conduction. This is heat transfer as a result of molecular contact. The best way to understand conduction is by thinking about an example. So here I have a metallic spoon, and I imagine holding a match underneath it. Now what we know is that that spoon is going to heat up, and not just the part of the spoon that's over the match, but rather the spoon as a whole. And the reason this happens is because of conduction. Energy from the flame is causing the molecules within the spoon to vibrate, and that's transferring energy from one to the next, to the next, to the next, until the entire spoon has warmed up. That heat has transferred throughout the entire material. Conduction is going to happen most effectively in solid materials. But let's not forget about convection and radiation. Let's look at convection. This is heat transfer through or as a result of density differences. Again, let's grab that match, and let's think about this for a minute. I think we all know it's probably not the best idea to hold your hand above an open flame like this, and that's because a lot of the heat energy generated by that flame is going to rise. That is purely because of the process of convection. You see, what's happening is the flame is causing the air to expand. And when it expands, it becomes less dense than the surrounding air and therefore floats upwards. And with it goes some of that heat energy. That's what convection is all about. And this is going to occur most effectively within liquids and gases. Finally, let's think about radiation. Radiation is heat transfer by wave motion. Let's pull that flame up one more time. I think we know that because of convection, heat is going to rise, but it's also going to travel outwards in the form of waves of energy, electromagnetic waves. And that's the third type of heat transfer. Radiation is really interesting in that it doesn't need a material for it to travel. So this can occur out in open, empty space. In fact, this is how energy travels from Earth's sun to the surface of the Earth. And so if we look back, we have our three types of heat transfer: conduction, convection, and radiation. And it's important to know the key word that goes with each one. For convection, it's going to be density differences. For conduction, it's going to be contact. And for radiation, it's going to be waves. We can sum all three types of heat transfer up in one diagram by looking at something as simple as a campfire. Imagine that you're camping and you hold a pot of water or stew above that flame. Well, right now in this one picture, we are seeing all three types of heat transfer take place. There's conduction happening as the flame is transferring energy directly to and throughout the pot as a result of molecular contact. Additionally, there's convection as heat from both the boiling pot and the flame itself is rising up as a result of density differences. And finally, there's radiation occurring all around the campfire as energy travels away from the flame in the form of electromagnetic waves. And that's a quick look at...
So turn with me to page 12. We're going to read paragraph 6 on page 12. Convection is the transfer of heat by movement within a fluid. The fluid may be a liquid, such as water, or a gas, such as air. Heat is transferred within a fluid when warmer areas of the fluid rise and cooler areas sink. The circular movement of fluid caused by warmer areas of the fluid rising and cooler areas sinking is called a convection current. So, if you don't mind getting your highlighter, we are going to highlight the very first sentence in paragraph 6. Convection is a transfer of heat by movement within a fluid. Then use one of your colored pencils And I want you to circle the word fluid in sentence 2, as well as underline liquid and gas. That is how convection is transfer of heat. So, in order to really understand this, they talked about the convection current, which is a cycle of cool air being pushed down, and we have warmer air being pushed up to a less dense area. We know heat rises, cold air goes down, cooler, and there, whenever you know that, you have the down arrows, the up arrows. Cooler air is dense, warmer areas are less dense. You have a circular motion called a convection current. All right, so we know convection is the transfer of heat and fluids. So we have our convection oven here, which the fan that kicks on from the heat coming from the bottom of the stove will circulate around to fill up all the cold areas. We have the radiator in your parents' car. If you blow it, well, that steam will rise out of there somehow. And we have our convectional rainfall. We have the sun shining down, heating the ground. We have condensation, moisture forming in the form of rain clouds, and it's an ongoing process. A convection current. So on page 13, we need to draw in the last box under convection. We have drawn in from the first two, so I want you to think about something that you can draw for convection. We've talked about a few things. You can talk to your teacher about it. We filled in radiation and conduction. Convection, like I said, we went over a few things, and then also we've seen some videos, so you should be able to come up with something to draw in that box. So please do so using your colored pencils.